Hello class. Today we will be going over section 7.7, solve right triangles. Turn to page 479 and look at question 3. Okay, problem 3 says using inverse tangents. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So the first thing that I want you to remember is your acronym here. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Very important that you remember your trig ratios. Also on your graphing calculator, you want to make sure that your mode is in degrees because we're dealing with degree measures. You also want to put your calculator on different settings. For this question, it says round to the nearest tenth. So you want to go to mode, float, and then the tenth place, you want to move it over to 1. So we have talked about these different keystrokes on the calculator already. So you should be very familiar with how to make sure it's in degrees and make sure that you have your float on 1. Look at number 3. So on number 3, I have a right triangle. The question wants me to find angle A. So my theta is at angle A. If you notice, I labeled my hypotenuse, my adjacent, and my opposite side. If I look at the given information, I have 12 and 18, which is opposite and adjacent. So for my trig ratios, I want to see which formula has A and O in it. And I can see that the tangent formula has opposite and adjacent in the problem. So if you notice, I said tan A because we're working with angle A. Opposite is 12, and my adjacent is 18. Now, on the calculator, we're doing something a little different. So you want to definitely practice. But if you notice on the notes, I wrote down what your keystroke should say. Your keystrokes, you will press second, then tan. And we're looking at the tan inverse button. So to get to the tan inverse, you have to hit second, then tan. On your calculator, you'll see a tan, and it has like a -1. But the way you read that is you read it as tan inverse. But it looks like a tan with a -1 as an exponent. So we will press second tan, then your numerator, which is 12, divided by 18, then close parentheses, and let's hit enter. So once you press enter, the measure of angle A is going to be approximately equal to 33.7 degrees. And remember, it says round to the nearest tenth, so that's why I have that 0.7 degrees. And that's my answer for angle A. We can find our answer for angle C by using the triangle sum theorem. So we already know how to do that. We know that the triangle sum theorem tells us that all the interior angles of a triangle equals 180 degrees. So we know how to find C if we needed to find it. Going on to the next question. The direction says use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So for number 7, again, we're looking for angle A. Looking at angle A, I labeled my adjacent side, my opposite side, and my hypotenuse. So if you notice, I have a number for adjacent and hypotenuse. Can I find my opposite side if I needed to? Yes, I can. I can use the Pythagorean theorem, which we know is a squared plus b squared equals c squared. So if I needed the opposite side, I can find it by simply applying Pythagorean theorem. But I don't need all the information. Since I have 2 side measures, I can easily find angle A. So I have to figure out which of my trig ratio has adjacent and hypotenuse in it. And I know that my cosine has adjacent and hypotenuse in it. So for my adjacent, I'm going to plug in 6. And then for my hypotenuse, I have 10. So again, I use the same keystrokes. I'm going to say second cosine. And I'm looking for the cosine inverse. Then 6, divide 10, close your parentheses, and then hit enter. And once I do that, I have the measure angle A, which is approximately equal to 53.1 degrees. And that's round to the nearest 10th place. Very important that you study the key concepts that's on page 477. And it tells you about the different trig inverses. Look at number 11. Number 11 says, solve the right triangle. Round decimal answers to the nearest 10th. So this time, we have to solve every missing piece. We know that in a triangle, just a triangle, but we're talking about a right triangle. We know in a right triangle, we have 3 angles and 3 sides. So I need to find all 3 angles and all 3 sides. If you look at the information, I've already have 2 of my angle measures. I have 9 degrees and 65 degrees. But I need to figure out how can I find angle N. I can easily find that so many different ways. But the simplest way I can find that is by applying the triangle sum theorem. So if you look at it, I know that my interior angle should always add equal 180. So I'm just doing a little shortcut. And I'm going to say 180 degrees minus 90 degrees minus 65 degrees. And that equals 25 degrees, which is going to give me the measure of angle N. So I have all 3 of my angles given to me. Now I need to find my 3 sides. I already have 1 side given, and that's 10. So I need to find my hypotenuse and my x, okay? If you notice, I labeled 65 degrees as my theta. So that is the angle I'm going to work with to find my other 2 missing sides of my right triangle. So if I make 65 degrees my theta, that means that 10 is my adjacent, my x is my opposite, and of course, your hypotenuse is always going to be that slanted side. So this is the side that never changes. But we do know that adjacent opposite can change depending on what my theta is. Now, since we have theta and my adjacent, I want to figure out which formula can I use that has adjacent in it. And I know already that cosine and tangent have adjacent in its ratio. So I can use either one. But if you notice, I just chose to use tangent. So I have tan 65 degrees equal opposite, which is x, over adjacent, which is 10. Cross multiply. If I cross multiply, I have x equal 10 times tan 65 degrees. On your calculators, and you know how to do this already, you're just going to say 10 times, just hit the tan button, 65 degrees, and x is 21.4, which is side NP. So we have 21.4, which is my side NP, which I labeled as x. Very important. I don't want you to get confused. Whenever you're looking for a missing angle, you hit that second, then the tan, cosine, or sine button. But when you're finding a side measure, just a side measure, you only press tan, cosine, and sine. That's it. So very important. You only hit that second button when you are looking for an angle measure only. So be very careful with that. Don't get confused on when to hit the second button, okay? But again, when you're doing a problem, you type in what you see. I see just tan, so I just hit tan. Okay, so now I need to find my hypotenuse, which is R. Okay, so if I look at, I use 65 degrees as my theta again. So I need to figure out which trig ratio has hypotenuse in it. And I know that sine and cosine has hypotenuse in it. But this is so important. since I have 65 degrees, that was already given, and 10 was already given. I really want to work with the formula that has adjacent and hypotenuse in it only, because even though I found X, my answer might be wrong. It could have been wrong, but I know for sure that 10 is not wrong because that was given information. So when you're deciding which trig ratio to use, always go with the information that was given to you first. And if that doesn't work, then you go with what you had to calculate. So I want to look for the trig ratio that has adjacent and hypotenuse in it. So I know cosine will work for that. Cosine is adjacent over hypotenuse. Cross multiply again. So I have r times cosine 65 degrees equal 10. To solve for r, I have to divide both sides of my equation by cosine 65 degrees. Cosine 65 degrees both cancel to 1. On your calculator, you're going to type in 10 divide cosine 65, and that's approximately equal to 23.7, which is side NQ. Before you move on, you want to make sure that the answer makes sense. I know that side QP is 10. I know that side NP is 21.4. And I know side NQ was 23.7. And I know that this side here is my hypotenuse. What do we know about hypotenuse? We know hypotenuse is the longest side of a triangle. We know hypotenuse is opposite of 90-degree angle. We know hypotenuse is the biggest number. So the answer makes sense. Okay, look at the next example. It says solve the right triangle, round decimal answer to the nearest tenth. Now I'm going to be honest, when I look at angles, I use round angles to the nearest whole number. And when you're dealing with side measures, I probably round that off to the nearest tenth. So you have to be careful with that. But since the direction says round to the nearest tenth, I'm just going to round everything to the nearest tenth place. For number 15, again, we're looking for 3 sides and 3 angles. If you look at the given information, I have 2 sides and only 1 angle is given to me. I don't have anything else. So I have to find my 2 missing angles and my 1 missing side. Since I know this is a right triangle, I can easily apply my Pythagorean theorem, which we know is a squared plus b squared equals c squared, c being the hypotenuse, the a and b being my legs of the triangle. If you look at my legs, I have 14 squared is 1 leg. I don't know the second leg, so I'm going to say plus b squared equal my hypotenuse, which is 16 squared. I know this is my hypotenuse because it's opposite of the 90-degree angles. That's how I know that's the hypotenuse. 14 times 14 is 196. 16 times 16 is 256. Solving for b squared, I'm going to say b squared equal 256. And then when I move the positive 196 to the right, it becomes negative 196. Okay? Subtract 256 and 196 to get 60. And if you notice here, I did a factor tree. We have talked about this several times. You want to do a factor tree here. So I know that 60 times 10 is 60. 2 times 3 is 6. 2 times 5 is 10. Every prime number I wrote under my radical, I see a pair of 2s. I see 1 pair of 2. 3 and 5 does not make a pair. So I just multiply 3 and 5 back together to get 15. So my radical answer is 2 squared root of 15, but it did say round the decimal answer. So I converted that to 7.7 in decimal. Okay? Now I want to find angle J. So to find angle J, I made J my theta. So if J is my theta, and I have all 3 sides, so I can use any trig ratio I want because I have all 3 of my angle measures. But again, remember what I said. Go with the given information. So on the given information, they gave me, if J is my theta, they gave me the hypotenuse and the opposite. So I want to use the formula that has the opposite and hypotenuse in it. And my sine formula has that information. So I have sine J equals opposite, which is 14, over my hypotenuse, which is 16. Again, on your keystrokes, we're going to say second sine 14 divide 16, open close parentheses, equal, and J is approximately equal to 61.0 degrees. But again, if I was just doing this on my own, I would just round it off to 61 degrees, and that's it. The next step, I want to apply the triangle sum theorem. Now, you can use your trig ratios again and find out what the angle G is. You can do your trig ratios again, but since I have two angles already given to me, we're going to keep it simple and just apply the triangle sum theorem. So 180 minus 9 degrees minus 61 degrees is 29 degrees, and that is my measure for angle G. Last little part, very easy, because it's just all calculator. It says let angle A be an acute angle. Now, what is an acute angle again? We know an acute angle is an angle that's less than 90 degrees in a right triangle. So if we know this already, we know that whatever our answers are going to be, they're going to be a number less than 90. So very important that you know the vocabulary. Approximate the measure of angle A to the nearest tenth of a degree. So again, we want to make sure our mode is in degrees, and we want to make sure that when we go to mode, we have our float on 1. We don't want it on float, we want to put it on 1, okay? All right. Looking at 21, it says sine A equals 0.5. So if I'm looking for the measure of angle A, I have to hit that second button on my calculator. So my keystroke is second sine, type in the 0.5, close parentheses, enter, and I have 30 degrees. On 23, I have cosine A equals 0.33. So I want to find out what angle A is. So to find angle A, I have to say second cosine 0.33, close parentheses, enter, and my measure of angle A is 70.7 degrees. On 27, I have sine A equals 0.19. My keystroke is second sine 0.19, close parentheses, enter, and the measure of angle A is approximately equal to 11.0 degrees. Okay, so hopefully this was very helpful. It is so important that you know how to key these different trig ratios into your calculators. Very important. What's key when you're dealing with a degree measure, you want to always keep that mode in degrees. But when you're dealing with radian measures, and that's something that you'll really see in your later math classes, you want to put it in radians when you're doing radian measures, okay? All right, study.